We're going to start talking more about inverses of functions with restricted domains. We've already talked about rational functions and their inverses, and they have restricted domains. But now we're going to concentrate more on our polynomials with an even degree and then our radicals with an even index. With our polynomials with even degree, we need to restrict the domain to make sure that our polynomials are one-to-one. Because remember, when we had, for instance, our parabolas, so the x squareds, this guy didn't pass the horizontal line test, which means that he would have no inverse. However, if we restrict the domain, so we only have half of the function, suddenly we do pass the horizontal line test, which means we have a yes inverse. Right? So that's what we're going to be doing with our even degree polynomials. And then when we're working with radical functions with an even index, remember index is the number on the radical. The domain is restricted to be greater than or equal to 0 because we can't take the square root of a negative number and remain real. We get into the world of the imaginary. So let's go ahead and take a look at our first example. We have a radical function, and this guy's index is 2 because we have a square root. But when we're finding the inverse, we're going to solve it the exact same way that we've been doing it. So our first step is to replace our h of x with our y. And our second step is to flip the x and the y. So we're going to have x is equal to 2 square root of y minus 7 plus 1. And we're solving this new equation for y. So I'm going to rewrite my equation with my y on the left side, my x on the right. And that's just a personal preference. You can solve it with the y on the right-hand side if you'd like. But we need to start working to get our radical function by itself. So we need to subtract the 1 from both sides. And in doing so, we get 2 square root of y minus 7 equal to x minus 1. We can't square both sides yet to get rid of our radical because we have that 2 out front. So we're going to divide both sides by the 2. And we finally have our radical by itself on the left-hand side. The x minus 1 over 2 on the right-hand side. And because we have the radical by itself, we can finally square both sides of our equation because we want to get rid of the square root. If I would have had a 7th root, I would have taken everything to the 7th power. If I had an 8th root, I would have taken everything to the 8th power. But here, I'm just taking it to the 2nd power because the square root and the square cancel each other out, which means we are now at y minus 7 equal to x minus 1 all over 2, quantity squared. Need to get the y by itself. So we're going to add 7 to both sides of our equation. We get y is equal to x minus 1 over 2, quantity squared, plus 7. And then our last step is to replace our y with our inverse notation. So h inverse of x is equal to x minus 1 all over 2 quantity squared plus 7. Make sure that you keep the parentheses around our fraction. Now that we have our inverse, we can start to find our domain and range of both our original function and our inverse. So domain, range, give myself a chart again. Need to give myself a little bit more room than that, because we do have restrictions. It won't be as nice as when we have negative infinity, positive infinity. All right, so if we're looking at our original function, h of x, we said we have a radical function. So looking at the domain of h of x with the radical function index 2, which is even, we need to take our x minus 7, what's under the radical, set it greater than or equal to 0. We solve this by adding 7 to both sides, and we get x is greater than or equal to 7. This time, we didn't have a restricted value where we just cancel out that one value. It says that we need to be greater than or equal to 7. So we're going to start at 7 with a bracket because of that equal to sign underneath. And we're going to shade up into the positives, which means that our domain of h of x is 7 with a bracket to infinity. And if we found the domain of the original, we found the range of the inverse. Now let's look for the domain of the inverse. If you look at our inverse, it is a polynomial function because there are no negative exponents, there are no fractional exponents, there are no variables in a denominator, but we can't have negative infinity, positive infinity for its domain because then the function would not be 1-to-1, which means it can't have an inverse. So for the first time, our inverse function is not helping us find the domain. Well, that's a bummer. But remember that the domain of one is the range of the other. So let's look at the range of our original function. We said that the domain was x had to be greater than or equal to 7. So if we look at our function, the original, if we plug in that x equal to 7, we would have 2 times the square root of 7 minus 7 plus 1. That gets us 2 times square root of 0 plus 1, which gets us 1. This is our starting y value. We just found the ordered pair on the function 7, 1. Okay, so our y value is 1 starting out. We need to figure out if our y values are going to get bigger or if they're going to get smaller. If they're going to get smaller, it would be negative infinity to 1. If they're going to get bigger, it'll be 1 to infinity. So let's see what happens if x is equal to 8, the next number in our domain. We would have 2 times the square root of 8 minus 7 plus 1. 2 times the square root of 1 plus 1 gets us 3, which means that we are getting bigger. So the range for our function is going to be 1 with a bracket because we actually hit the y value, to infinity because we keep getting bigger. And if we found the range of one, we found the domain of the other. So we worked backwards and found the domain for our inverse. Let's look at example number 2. This time we have a polynomial function because we have the x plus 7 quantity squared, and they give us the restriction x greater than or equal to negative 7. So let's go ahead and start this like we always do. We're going to have y is equal to 3 times x plus 7 squared plus 4, and I'm going to carry down my restriction because that's going to come into play for our inverse. We know the rule is whenever we have our inverse set up, we need to flip our x and our y's. So I'm going to have x is equal to 3 times y plus 7 squared plus 4. And this time, instead of x greater than or equal to negative 7, we're going to do y greater than or equal to negative 7 because the y is replacing the x. I'm going to rewrite this so that my y is on the left side. So 3 times y plus 7 squared plus 4 equals x. My y greater than or equal to negative 7, I'm just going to carry along. Solving our equation for y, we need to subtract 4 from both sides. We get 3 times y plus 7 squared equal to x minus 4. Need to get the quantity squared completely by itself before we can get rid of it, just like with the radical. So we're going to have y plus 7 squared equal to x minus 4 over 3. We know that a square root gets rid of a square. So we are going to take the square root of both sides of our equation, but we need to remember that the plus or minus happens when we have a square root being taken on both sides of an equation. And the plus or minus doesn't go with the square, it goes with the fraction. And we did this because the square root and the square take care of each other. And we have y plus 7 equal to plus or minus the square root of x minus 4 over 3. We need to subtract our 7. And we wind up having y is equal to negative 7 plus or minus the square root of x minus 4 over 3. We have two separate answers. Y is equal to negative 7 plus the square root, or y is equal to negative 7 minus the square root. Remember, inverses are 1 to 1. You cannot have two inverses. Okay? When you're married, the state and the government only recognize marriage to one person at a time. If you want to talk about The Bachelor or some other cheesy dating show, you only get to wind up with one person at the end. You got to make a decision. And this is where that whole y greater than or equal to negative 7 comes into play. Okay, so for here, y greater than or equal to negative 7, you need to think about which one of these inverses will make us bigger than or equal to -7. The first one makes us add. The second one makes us subtract. By adding, we'll get bigger. By subtracting, we get smaller. Since we want y greater than or equal to -7, we're going to go with y getting bigger. So we're going to take our inverse to be -7 plus the square root of x minus 4 all over 3. Now that we have our inverse, we can find our domain and range of both functions. I'm going to write my little chart. And we have our original. We have our inverse. The domain of the original, they already gave us. They gave us the domain before they did anything else. They said x had to be greater than or equal to -7. So if x is greater than or equal to -7, we're going from -7 on up into the positive infinity. So we're going to have -7 to infinity, bracket around the -7, parentheses around the infinity. If we found the domain for one, we found the range for the other. So the inverse range is -7 to infinity. Let's look at the domain of the inverse. The domain of the inverse, this guy is a radical function, and it has an index of 2 because it is a square root. And because it is even, we are going to take our radical, or what's under the radical, x minus 4 over 3, set it greater than or equal to 0. You're going to multiply both sides of the equation by 3 to get rid of the fraction. Left-hand side, they cancel out. Right-hand side, 0 times 3 is 0. Add 4 to both sides, we get x is greater than or equal to 4, which means we're going to have a bracket at 4, shading up because we need to go greater. And we just found that our domain of our inverse is 4 to infinity, which means that the range of our original is also 4 to